Assalamu alaikum wa rahmatullahi wa barakatuh, everyone. So, I recently became interested in the direction of the Qibla in North America. It was always been my understanding that the Qibla is northeast, and that's always made sense to me. And then recently I heard about some rulings, and I've also seen some masjids in the United States or specifically the northeastern United States, where the Qibla is actually southeast. So, I thought an interesting sort of experiment would be to look at the globe, using Google Earth and actually kind of see which one made sense. This is not an attempt to kind of replace fiqh rulings or the proofs from the Quran and Sunnah, but ideally the Qibla is a direction, and visually the direction should be able to make sense just looking at the direction on the Earth. And of course, the difference between the Qibla being northeast as opposed to being um, southeast is pretty significant, and it should be something that you can definitely see quite clearly on the map. So here I have uh, the globe, our beautiful Earth, with the points San Francisco and New York showing, just as an example to begin from here. One of the challenges of representing you know, arcs or curved distances joining 2 points on a sphere, or in this case, the globe, is that in fact what we're really looking at is a flat image. The eye has the illusion that this is a sphere, but in the end, what we're seeing is projection, a projection of a 3D object, which is a sphere, onto a 2D plane, which is the screen that you're looking on the YouTube website, or me on my screen right now. And the challenge with that is representing arcs and curves on the sphere in 2D. And it can be a very difficult thing because if it's not aligned properly, you can draw a line. Here I have San Francisco to New York, and I could easily just draw a straight line from here to here and say, well, that's the direction from San Francisco to New York. That's the direction I need to take. Um, but, you know, that's a straight line, but you're drawing a straight line in 2D, but really you're projecting, a 2D line onto what is really a 3D model. Really, what you'd want to do is if you wanted to join or draw a path between San Francisco and New York, you would do something like that. And we see it's slightly curved. Now, if you wanted to represent this curve or this kind of arc on the surface of the Earth joining San Francisco and New York, what you'd want to do is you'd want to align your sphere so that the arc looks like a line. If you're flying over an arc bridge or some kind of arc and you look directly over it, it looks like a line. And when you do that, and if I can do that right here like this, I hope that's clear. It's about a straight line. Then we can easily do a straight line joining San Francisco and New York, and we can say that straight line does represent the correct path that we take to go from San Francisco to New York because we've oriented our 3D sphere to properly represent the directions in 2D. Now, what I want to make clear before I actually start discussing the Qibla and taking a look at the path from the northeast United States to Mecca Mukarramah is that this path between San Francisco and New York is actually the shortest distance. It's the shortest distance. Google Earth has drawn the shortest distance between San Francisco and New York. But that's not the important point. The important aspect of the shortest distance is a matter of direction. What do I mean by that? If you were, say, to embark on a journey by walking from San Francisco to New York, your direction, your heading from San Francisco to New York would never change along this path. That means you can walk from San Francisco all the way to New York without ever having to adjust your direction, meaning that when you arrive at New York, you can do a 180 turn and you'd be looking straight back at the path in which you took. Now, that's not the only path that you can take to go to New York. You can take a very slightly curved path and go through the United States. Let's say you're flying, go over the Great Lakes and come down to New York. You can do the opposite. You can go down into the southern United States and come back up. You can even take a more extreme curve and go into Canada, down into Ontario, down through my hometown of Toronto, all the way down to New York. You know, these are all paths, and you can draw them as being paths between San Francisco and New York. But what you don't realize is if you did take those paths, you would have to continuously change and adjust your direction in order to finally meet your final destination, which is New York. And the reason why is very simple because your initial direction was not exactly correct. And that makes sense. If you imagine yourself driving up to from San Francisco into Canada, inevitably you're going to have to make a bunch of right turns to inevitably reach New York. And the same thing if you decided to go south and then all the way back up. This is not the case with this direction that I've drawn here from San Francisco to New York. It is a straight direction where you'd never have to change your bearing or your direction, so to speak, if you were walking or taking a flight. And this is an important issue. So let's remove this path and let's take a look at New York as I've marked here. And here we also have Mecca, the sacred city of Mecca. And let's draw the path from New York to Mecca, which I've drawn here. Okay? So again, let's consider a similar argument. You know, there's many paths that you can take from New York to Mecca. In this case, you know, I've just had Google Earth draw the arch, and it draws, you know, the shortest length arc. But the argument is still the same. If you take this direction as shown, your direction or your bearing towards Mecca would never change. That is to say, if you were to walk or you were to fly, you would never have to adjust your bearing or your direction at all throughout this entire motion. That is, when you hit Mecca Mukarramah, if you did a 180 turn, you'd be looking straight back on the path that you took. That's not the case if you look at, for example, some of the arguments for the southeast direction. And let's say we draw this path. And, you know, this is just a very skew. I don't mean to kind of make the argument for the southeast path look not that great, but this is just a mock drawing of a supposed path beginning southeast, beginning at the edge of the eastern United States, moving southeast, and then finally coming up and hitting Mecca from the southwest. Now, this is a path. It joins New York to Mecca. It makes sense to me, or supposedly it makes sense. It's joining New York so to Mecca, so why not have it be the direction of the Qibla? But what you don't realize, it's a very subtle point, is in order to draw this line, you are continuously changing and adjusting your direction to finally hit your final destination, which is Mecca. You don't realize that when you're drawing. You just draw a curve and you say, this is the direction. It makes sense. If I face southeast, I'm going to finally reach or be pointing at Mecca. But in order to draw this, you're gradually changing your direction. You're adjusting it. You're compensating for the fact that your initial direction was not the same. Whereas in the case of this path drawn here, right, the direction is straight and it doesn't change at all. And if we, again, like I said initially in this video, if you kind of align, let's remove the southeast path. If you kind of align this as a line, as you move this so that the arc joining New York and Mecca is projected as a straight line, you get a good sense of the fact that this is a sensible, reasonable direction compared to any other directions, whether you swoop downward, southeast, and then come northeast later, or if you decide to go further north and then decide to come down. This seems to be visually the best path. Okay? Now it's very interesting, but if you look very closely, look at this path relative to the North Pole as well as these latitudinal lines. You see that if you focus on New York, you actually begin by facing northeast. And then the path takes you to the point where right at the center, like right in the middle of Atlantic, your direction is east. Now this is all relative to the fixed directions of north and east. and then inevitably your direction is changing